Hello, my Nerdy-Nawg-Dawgs. Quick video. Just want to remind you, how do we subtract from a whole? Well, we have to think about all of our fraction rules that we know, right? We know that I need to have a like denominator to subtract. Is this like? No, but we also know the most efficient way to turn a whole number into a fractional unit is to multiply the whole number by the fractional denominator. So if I want to turn a 5 whole number into ninths, all I need to do is multiply the 5 by 9. That would give me 45. Now my answer, I'm sorry, 45, and I write down 49. That would give me 45. And I write that down over ninths. But I want you to remember, why does that work? Why will that work? Again, math trick. I'm turning that 5 into the fractional units of ninths. That works because I know that there is 1 whole there, 2 wholes, 3 wholes, 4 wholes, and 5 wholes, right? So this 5 being a whole number could be represented as 1 plus 1 plus 1 plus 1 plus 1, or 5 total. Now, what is one way to write 1 whole if I'm dealing with the fractional units of ninths? Easy! You guys know how to do that. Isn't 9 ninths the same as 1 whole? Yeah. So to represent that 5, I could write that as 9 ninths. Oh, let me write it down here. I could write it as 9 ninths plus 9 ninths plus 9 ninths plus 9 ninths plus 9 ninths, right? 1, 2, 3, 4, 5. If each of those equals 1, that's equivalent to 1 plus 1 plus 1 plus 1 plus 1, that would equal 5 total. So that's the same as 9 ninths, and therefore, if I were to follow my fraction rules, my denominator stays the same. When I'm adding like fractions, I can add these because they all have the same denominator. So that my answer is also going to be a ninth. But then I add the numerator. So let's do our multiples of 9. 9, 18, 27, 36, 45. So that would give me 45 ninths, the same as we got here. So again, that's why it works, and that's how you can turn a whole number into a fractional unit. Then we can move right along with our math. So I'm going to change that 5 whole numbers into 45 ninths. And then I can subtract the 2 ninths. And my answer ends up as 43 ninths. Now, can I leave that as my final answer? Why, no way, says Ms. Nogdave, right? That is improper. He does not put his pinky up when he drinks his tea. It's improper. We may never leave that as our final answer unless you've been asked to leave it that way. So then my next question comes into play. Well, I know my holy grail. That fraction bar actually means divide. So this is the same as saying 43 divided by 9. So we can think of it, if I have a pen that works, we can think of it like this: 43 divided by 9. And I don't actually need to do my long division on this because I know my multiples. So I can do some of that in my head, and I say, well, 9 will go into 43. I know it goes into 45 5 times. And that would get me too high. So therefore, I know that 9 will go in 4 times without going over. What is left? Well, 9 times 4 gave me 36. Therefore, I count up from 36 to 43, and that gives me 6 left over out of 9. My denominator stays the same. So close to being at my final answer. But no, why can 4 and 6 ninths not be my final answer, you ask? Well, I know that 6 and 9 have something in common, right? So 4 and 6 ninths, cannot be my final answer because they can both be divided by 3, and I could simplify that fraction. My whole number gets brought over because it stays the same. I simplify the fraction. 3 goes into 6 2 times. 3 will fit into 9 3 times evenly. 2 and 3 cannot be divided by the same digit. Therefore, it is in simplest terms. And there is my final answer. Okay, so long story short, to make a whole number into a fractional unit, multiply it by the denominator that you want to make it into, right? And then the answer goes over that denominator, in this case, ninths. That's our math trick for the day. Okay, keep going, Nerdy-Nawg-Dawg.